Hello and welcome to another special Sudoku solves video. Today I am not continuing the Sudoku Vania yet. I want to do that in more stages, so I can, think about the puzzles. I got a comment from Skeptical Mario explaining the part where I bifurcated, which I really enjoyed. Uh, I don't know. I didn't. It was something more or less pretty simple, but I just didn't spot it. But that happens in Sudoku, I guess. Um, but today I found this puzzle, Yin-Yang-Yong. So let's start and we'll see what that like entails. Because it's a three-colored yin-yang puzzle. So there are three shading orientations: light, medium, and dark. We'll use these three colors, I guess. Are they? Yeah, they are different enough. Light, medium, dark. They are different enough. But I want to use. Okay, so they have normal three-color yin-yang rules. The digits on a tail of an arrow sum to the digit in the bulb. So let's pick this one. If that's an 8, it sums to an 8. That's that. Um, A tail of an arrow has the same shading orientation. Uh, the tail of an arrow has the same shading orientation across its length, but must have a different shading orientation to its bulb. Okay, so there are three colors. We need to keep that in mind. It's not okay. And then chaos construction. Construct a 9-cell region. Construct nine cell regions in the grid. Each region must be entirely composed of the same shading orientation. Crop key. Okay, that's just normal. Okay. Um, I'm gonna spend some time choosing a color for the regions because I'm not gonna use black if I use black here. I think red. Yeah, I think I'm going to use red regions for this puzzle. Let me go back. And just to remind myself, red across the edge. Um, so yeah, okay. Let's start, I guess. One thing I spotted when looking at the puzzle, that's this 4-cell arrow, because in my head I was like, well, that's impossible, right? Oh, that's barely visible. Okay, I'm using these middle colors. That's still rough, but that's okay. Um, then I don't need to use the red, I guess. Okay, so I'm going back on that. I'm going to just use black. I'll remove this bit again and make everything black again. Um, I saw that 4-cell region and I immediately thought, well, that's a problem, right? Because they all have to be different digits, but they don't. The chaos construction regions are different. So, for example, this can be a chaos construction edge, or this can be a chaos construction edge. So that is interesting for this arrow, though, because still within each row there have to be all different digits. So this is at minimum already 6. So that can be a 3, I guess. It can be 1, 2, or 3. And this can be at most 8. So I'm not able to put a 6 in here. So it's the numbers 1 through 5, but I'm not going to pencil mark that yet. So now, okay, so every yeah. That's I think that's a fine point to make. Um, I'm gonna start with a few things. I'm thinking about a few different things. The first thing, can this ever be purple? Um, be not purple is a better question. If this is orange, it has to go out, and it has to be more orange, and then the arrow is the same color as the bulb. So this bulb is purple, and this has to be a different color to that bulb. So we'll make that orange for now. Now the second thing, within a yin yang puzzle, you have this concept, right? That whenever you have two yin-yang colors, this is not able to form, because if it does, if you connect the purples together, you isolate an orange. But I don't know how that works with three colors. No, I think that's still a problem. Do No, I don't think that's a problem. Construct a shading grid where all shading orientations themselves are orthogonally connected. So in this case, you can just have purple around here and green in here, and it's fine. So this is possible. However, this isn't. No, this isn't. So you cannot have a 2 by 2 checkerboard pattern of two different colors. Of three, it is possible. Of two, it isn't. Okay. So how do we extend that to the edge? If this is all green, this is all purple, and this is all orange, can we have purple again? And I think that's fine. Yeah, that is fine. And we can have orange again. Obviously, I know this doesn't work because of this, but so can we have, after this orange, can we have another purple? Now, and that does break because that isolates that orange from that orange. Okay, okay. I think I got a grasp for how all of this works. So how it how it's how it does work is this breaks, right? Because you isolate it and there's already one on the edge. That breaks. Okay. So let's see what happens up here then, because all of these are the same. And I'm going to use, these are my confirmed colors, these are my hypothetical colors. That's going to be blue, and that's a different color. Now, well, I don't even know. How many color, light, medium, and dark. Construct a shading of the grid where all shading orientations themselves are orthogonally connected. Note composed of entirely one shading orientation. So whatever this is a different one. But also this. Hmm. I'm not sure. What we do know is that, okay, so maybe let's think a bit more about chaos construction, right? Because what they said is all chaos constructions, yeah, must be composed of the same shading orientation. So this is a border, this is a border. Now the problem is either this is a border or this could be a border, I guess. Yeah. If if this is a border, then purple must grow out this way. If this is a border, purple must still grow out that way. So this is always purple, and that is always. Okay, so no, okay, that has to be orange. I was thinking, could we have just two cells of orange, and within the yin yang rules, that's totally fine. But the chaos construction rules don't allow that because every cell has to be part of a region, and every region has to be at least 9 cells of the same color, right? Yeah. If 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 this is the border, then purple grows up there or up there. If this is the border, it does the same thing. Yeah. So can we draw? We can draw distinctions within the borders. Here, here, there, there, and that's kind of it. Um, so either orange grows up here and isolates this one, or it grows here and it isolates that one. So there's either a border here or here. But that's okay. So this has to grow. Oh wait, I didn't even look at the white dots here. Because I think that's a problem. No, we can have 3, 2, 1, 2, and then we have 8. We can have 3, 2, 1, 2, 1, 2, 3, 2, and that's also 8. My question is, can it ever be a 3? And I don't think it can, because then that's a 2 or a 4. But, but 3, 4 is already 7, and then those two cells cannot end up summing to 2. So if that's a 3, that's a 2. Then we have 3, 4, that doesn't work. Or we have 1, and then it ends, so that's not a 3. Now, does that have to be a 2? If that's a 1, then that's a 2. And it goes to 1 and it breaks, or it's 2, 3, and then 4. And then 2, 3, 4 sums to 9 already, and that cannot be 9. So that's a mandatory 2. And that's either a 3 or a 1, and that's always a 2. And then that's a 3 or a 1. And that is always an 8. It could be orange. It could be the third color. But these two are different. So this 2 is part of a region. This 2 is part of a region. And the border is either here or it is here. And it's one of those two. Interesting. So this is also at least 6. So this follows the same thing, but it doesn't have the same restriction as this one because there's not a dot here. Mm, does this number have to repeat? No, it can be. Mm, can it be 1, 3, 4? That's 8. No, it does have to repeat. This digit does have to repeat in these. Because either it's a 3, and then we have 1, 2, 4 by the 3, that's 10 in total. It is 2, then we have 1, 3, 4 as a minimum, which ends up to 8, and that's also 10, or we have 2, 3, 4 with a 1. Yeah, okay, because then it's 4. Oh, I could have looked at it a different way. It's 4 different digits, and that sums to a minimum of 10, and that's not a 2-digit number. So what? So what now then? Um, do we need to look at more theory? Because we see there's a border here, right? And if that's all orange, that's all, let's say, green, and then that has to be all purple. That would be a logical conclusion, but the thing is, right, if this is all green, then this can all be orange. And then orange and green can fill up here, and whatever can fill up down there. And we're fine. Or purple and green don't need to touch each other. That's not a necessity by the rules. Themselves are oriented. Very cool approachable puzzle. Um, didn't reason about the way 3 colors would interact at first. Once it drew a bunch of lines across the other side of the road. Then it must be more chaos construction things. I was looking to see if maybe there is a rule where it said, um, how can you say properly? Um, where all colors need to touch. So purple needs to touch green because that does have an influence. That means we know the composition of the border, which would help greatly. And I might just assume that they mean that by where all shading orientations themselves are orthogonally connected. But I don't think that's the case within the wording. Um, at least I would word it differently. Maybe that's a bit of better reasoning. Uh, maybe a better comparison. So this is could this theoretically be orange, and then this. If this is purple, that's fine. If this is green, that does seem fine as well. I'm unsure. Well, okay. Then what now? These are the same color, so they must be the same as that one. So all these three are the same. There must be a region division here, and it can be either there. Could it be there? Yeah, it can. Or it can be there. But there is a region division. Okay, no. Wait, that. Oh no, that's not true. I was gonna say that's proof that uh, there's a color change, but there isn't. The region change doesn't mean the same thing as color change. I am going to assume all colors need to touch each other because I, if there is a different way of seeing this, I'm I'm not seeing it. In all honesty, um, so whatever what that means is let's say this is green now, and this is orange. Now we close off green from touching purple, and that's then not allowed by the rules. If we have the assumption that they mean that all colors have to be connected, which is very standard for these types of yin yang puzzles. So what that means is we know that this goes like that, this goes like this, and this goes like this. We can have at most one, two, three color changes. In normal yin yang, that's two. Could no, okay. So we cannot have any more interference other than this within the border. So it has to be like this. Now that does mean that this is green. Um, but that does not say anything else. Um, this is a different color than that one. This is a different color than that one. So this is the regions. This is a different color than that one. This could still be green, or this could be green. So that's not it. Um, um, I am looking, but I'm not seeing anything. Uh, what else does all this mean? Oh, the 8 and the 2 are looking at this. So that is a 3-6 pair. That's the only crop key pair that works. If that's a 6, that's a 1-2 pair. That is pretty significant. Okay. I had to sneeze for a second. I'm sorry. Um, let's see. Where was I looking at? Oh yes, this. Um, oh, I hate hay fever. Okay, I think it's called hay fever in English, but I'm honestly not sure. Um, so we have to find. Well, okay, so this is quite a. This could just be one region, but they could if it isn't, right? No, okay, so let's imagine this is not one region. That means this has to grow like that, but this also wants to grow out like that, and then we have a 2 by 2 of orange. So this is all one region, and we know it's this. Now, purple, purple down here is more than one region, but we know there's a barrier either there or there. Give me red. That digit and that digit are the same. So it is, what's the minimum? 7. 7, 8, or 9. And that's also then 7. That is 7, 8, or 9. The 3 cell region is 6, 7, 8, or 9. 3 cell arrow, I mean. So is there more region stuff we can do? Because this must have a barrier somewhere on it, right? Somewhere on there must be a barrier. These are both the same color. Do they have to be green, or can they be purple? They're either green or purple. If they're green, that's a different color. If they are purple, okay, no, I don't think they can be purple. If they are purple, right? Purple has to get out of this pocket somehow, and it has to take this arrow. But then it takes all 3 of those, and then we have a 2 by 2 of purple. So they're not purple; they're green. And then that is a different color, the same color as that arrow. But that arrow can be orange again because there is a region marked. It doesn't mean that the same color cannot extend behind that region. But what is true to say is that this arrow is not green, and this cell is not green. So that is region. And then the region is now 5 cells, 6 cells. So that is a different region. 6. That cannot be green. So that cannot be it's so many cell. Let's see, 5, 6, 7. So that's its 7th cell. Now it can take those two, and then this is a different region, or it can come down here, I guess. Now this cannot be green, so this region cannot connect to there. So it's like that. So that is also green. And that's now not green. So that's like that. But that can still be purple. Mm, maybe this is also a good way to mark regions that I found. Just so I kind of, just so I know, right? That's part of a region, but I can move straight down, or it can move up now. I don't like this marking, but having trouble keeping track of what's region and what's color, right? Um, this is definitely not green. All colors are touching one another, so that's not a aspect that I need to look out for anymore. So, for example, this can be orange, and then just cut through the middle here. Do both have to be the same? The digits on a till of an arrow, sum to digit. A till of an arrow has the same shading rotation across its length. So these can be different. But if they're different, this one is the third color. Okay. So this was 5, 6, 7. If it ends there, it takes 8, it takes 9. That is possible. If this is orange, it just hooks in here. If it's purple, it must come down this way. But the thing is, purple could just connect here, and then we the rest of this is a two-colored yin-yang puzzle. That that is possible. I don't see an issue with that yet. So maybe something else. Um, so how does this work now? Because it's a string of two digits. If either of these isn't one, so it's either 1, 2, 3. Because it cannot be 2, 3, 4, right? Because then you already have 9. So it's 1, 2, 3 with an extra digit. So this is 1, 2, 3. There's no. Yeah, so we have 1, 3, 1, 3, and that's a 2. So there is no 2 on this arrow. So that's not a 6. That's a 3. And that's a 6. And then this doesn't contain a 2, so the minimum it can contain is 1 and 4, making that 8. It could, yeah, yeah. So it's either 1 and 4 or 1 and 5. So this is 8 or 9. Um, but whatever it is, one of those is 1, I guess. If that's relevant, I don't think it is. Um, Now this arrow cannot contain 1, 2, or 3 anymore, so it contains 4 and 5, making that a 9, making that an 8, making that a 7, making that a 7. That's gonna make me remove that red circle because I don't like it anymore. Um, Making that a 1. That's a 3. That's a 1. So 1, 2, 3, 4, 5. So where are 4 and 5 gonna end up in this row? Because this area, this region is going to extend at least here. So 4 and 5 must end up there. And this must be a border. Oh, that's a red border. I want to make it a black border. like that. Exactly how we theorized it. So that's not going to be green because that isolates that one. Now this has to grow by 1. So this misses the 6 and the 8. And now we miss in this region, we're missing 1, 2, 3, 4, 5, 6, 9, and 7. So, or 7 and 9. That's a lot of progress suddenly. So this is now 1, 2, or 3, but it's not a 2. So this is 7 or 9. Now this region is interesting because whatever it is, whatever this is, it's going to come out this way. But this region could just be this, right? Yeah. I don't like this black line. Um, so many 3s and 1s everywhere. Let's see. What's a different relevant thing? This. Oh, since this is all a different color, and we can draw that border like this. Whatever this is, it's not that one, so it's not going to do this, so it comes out this way. So this connects up to that one, and it's not green. Now that's only 7, it has to come out another one. And it's still different than this one, that's why I drew the border there. But it could take this arrow because we can just draw the end of the region and the color can connect. But that does mean all shadings have to be in at least a multiple of 9. That is the only thing that comes from that, okay. Now this. It's not green. It could be orange. No, I don't think it can be orange. Because if it's orange, right, it can obviously not take this arrow because then we form a 2 by 2. So orange comes down here and then we create another 2 by 2. So it's not orange, it's not green, it's purple. And then that's purple. Now this cell cannot be this cell cannot be orange. So orange cannot grow. Orange is finished. We're done with orange. Now how is this region going to grow? Because this is not purple. So it must be green then. But we don't know if this is the same region though. Well, this is now not green and it's not orange, so that's purple. So that is part of a region. So that's a 3, that's a 9. That 3 makes that a 1, that a 3. That's weird. Okay. So these are part of a different region, but we don't know what the 7 belongs to. Okay, so that's 5, 6. No, that's 5, 6. This is now all purple. Coming back to something else. Let's see. Because this has to be part of the same region. So that's already 7, 8. And then we have a 9th cell, which is either that one or that one. But they don't have to be. But they could be. They could be. I don't know. But that's now forced to be green. So that's also green. That's now also forced to be green. We cannot have a 2 by 2 of two different colors. So that's purple. That is purple. Making that purple. Now we need region puzzles, right? Now it's more of a region thing. This region. If it okay, so if it doesn't, if it goes this way and it doesn't take cells down here, we have a problem because then this has to extend like that and it blocks in this purple. So this region has to come down there and pick up all of this, I think. Can it pick up just... No, it cannot pick up two. This can at most have this, right? So this has to be one full region. So this is a region. Now we have this finished, I think. 7, yeah, 9. So that is a full region. This is now 5 of size 5. One of these has to be green. If it's that one, then that has to be purple, and then we have an isolated cell. So that's purple, that's all green. Oh, that's green. So this is 4, 5, 6. So this is 6 cells that have to belong together. 7, 8, 9. So that is a forced region. Now this, let's say, oh well, that could still happen, right? That this moves up and then takes whatever cells, and then this moves in and takes whatever cells. I think there's multiple ways for that to work out. One of these cells is green and one of these is purple. Well, we know that that's green. Okay. Um, this 1 forces that to be a 1. And then that's the 4 or the 5. So what now? Because this can be different regions. Actually, how many regions do I have? This one's done. 1, 2, 3, 4, 5. This is probably a 6th, 7th. Then we have 8 and 9. Okay, so everything I have has to connect to something now. Okay. We know that this 1, 2, 3. Where are these 4 digits going to appear in this region? They are all here. So this is 1, 2, 3, and 7. Oh, with that one. Sure. Um, what can you add to 4 or 5? Because now this can be, you cannot add 1, so at least a 2. So the minimum you can make is 6. Oh, so this is 6, 7, 8, or 9, and it's not 8. Okay, it cannot be 9, I don't think, because if that's 4, you have to add 5, and then that's already a 5. It's that's 5, you have to add 4, and then that becomes the 4. So that's not it. So it's 6 or 7. So that's either 2 or 3. Because with 5, that becomes a 5-2 pair. Yeah, that is a 2 or 3. has to be something more. If well, okay, so either this is a border or this is a border, but whatever it is, it has to grow, right? So that is forced to be purple. So at minimum, at maximum is 5 cells now. So we need at least 4 more cells connected to it. And that's green now. And that's purple. Now you cannot make a checkerboard pattern. So that's 7. We need to grow by at least 2 more. But maybe even more. This green now has to grow. So that's all green. No, give me no, give me the 2s. Uh, we have to split the amount correctly, right? Is that what we are looking for? Because this can connect that way, this can connect like this can connect like this, and then that and that. It's always 2 greens and 2 purples what we have left over now. So it's a matter of dividing up the regions correctly. I think if we draw a border here, we have a problem. Because if we draw a border here, now this is how many cells? 5, 6. But now this has to grow as well. So, and this is the only way out. So this is not the border. This is the border. Now we can draw in a lot more. I think we can even finish the puzzle if I look at this correctly, because this now is 1 region and it's 9 large, so that's a border. That doesn't mean that that cannot be. No, 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 it does, because this is 7 and the last 2 cells have to be connected to this region. So I can only see this. Let's look at this then. 4, 4, yeah, that has to be green. Now that does have to be purple because it has to grow. This has to be purple to connect everything, and that has to be green. And now we have all the regions as well. So it's quite funny that there is only one orange region. Um, let's see, one of those is 9. That's 2. I'm quite struck with what I'm supposed to do. I see one more line that I missed. Um, I'm whoa. Okay. Uh, what do you want me to do? Yeah, puzzle game. Um, this arrow. These are the same. So what are they? Not 7, 8, or 9, and not 1, 2, or 3. So they're 4, 5, or 6. Oh, what did I do? Make them both orange, and then that's purple. So these are 4, 5, and 6. This 9 pair. I don't see any restriction on that. This, no. It must be just some trick, right? Within, like for example, where is 7 going to go in this column? It's not going to go there. It's only going to go there. So that's a 9. That's a 7. That's a 6. That means that's the minimum of 4 and 2. But now what does that mean? That that's a 5, I guess. Um, I hope that's not the kind of thing I have to keep spotting because I'm not good at that type of scanning. Um, but obviously that's a chance to get better, right? That's how we look at it in a more positive light. Um, we know that this is 8, so that's 4 with a 4. Now, where is 4 going to go in this region? It's going to go there. Please bless me with some easy chaos puzzling, regioning. I don't know. What is this? 1, 2. I'm missing a 3. A 3. Thank you. I'm going to go painting the upcoming week. Um, more, not like free painting, but more industrial painting, as work, I guess. Um, so I don't think I'll be able to record, but I'm very very excited to do the second part of the Sudokuvania experience. Even seeing skeptical Mario respond to the puzzle I did. That I don't know that I don't know. That's enjoyable. That's fun to see. Um, and even he he obviously knows a lot about Sudoku, and him taking the time to watch my video and um, give his thoughts on it. That really means a lot. And I don't know. Maybe I just didn't expect that, but it's good to see. Yeah, it's fun to see. Obvious. I think that's sort of clear. Um, Oh well, okay. So where's the 4 going to go in this column? That's the good old trick. Uh, the 1 and the 3 is the only way to make 4. I heard the doves outside. Let's see. That's not a 7. Okay, so no, it isn't relevant enough. I don't think. White dots always contain an odd and an even digit because they're consecutive. So what odd digit can be on there? It's either 9 or 5 because 1, 3, and 7 are already in the region. If it's 5, it goes with 6 because there's already a 4. And if it's 9, it goes with 8. So that's a pencil mark. Um, so what I'm doing now is I'm looking at this column, right? And I'm seeing, okay, a lot of these digits are already filled in. So that means that these 4 digits within this region have to fit here. So where is this digit going to fit? It goes to fit with the 2 here. So this is 2, 4, or 5. That's not a 4. That's not a 4. That's the kind of scanning I do when I do these chaos construction puzzles at the end. Um, but I don't know. I'm having trouble seeing that right now. So this 9 does block a lot because it blocks those, it blocks those. That's not a 9. So one of those two is a 9. But I'm not prepared to pencil mark that in. Um, threes? I have a lot of threes. Let's see. These can all not be three. Those can all be three. If that's a three, that has to be a four, and that's not possible. So one of those is a three. Yes. If that's a three, one of those is a three, and one of those is a three. If that's a three, then that's a three, then that's a three. So within these rows, we have all the threes basically allocated. So there cannot be a three in there, but there has to be a three in this region. It has to be in one of those two. Right? Sure. Yeah, that is true. Um, so one of those is a three. This cannot be four or six. So what can this be? It can be five. Oh, can be five, seven, eight, or nine. Not nine. What number do I have a lot of as well? Ones, maybe? One of those is a one. No. If there is relevance in that, I'm not seeing it. Okay, so where is four going to go in this column? It's there. That's four. That's five. And then I think we said whereas five going to be in this region is going to be here. So that's now not a four, and I'm going to remove that two pencil mark. Oh, there was a four in one of those, so I could have seen that before. B4. Haha, okay. That's that's such a dumb joke. Those are now not fours anymore. So what is this? One, two, three, four, five, or seven. And now this is not a four. So what? What else? What else? Still ones. I'm still looking at those. Why I don't know. Um, is there any rows that have something interesting in them? Because I know from my type of scanning that I look at columns a lot more than I do at rows, but I don't know. I'm not seeing any of it. Mm, six is any relevance? One of those is six, but sure. Um, fours. One of those is a four. One of those was also a one. So I can see a three. One, four, three. Oh, there's already a three in that region. No. Okay. Um, seven. Now, if that cannot be a seven, that would be great because then we have a seven in one of those. If that's a seven and this is a three, four pair, and that seems with a four there and a three there, which seems totally fine to me. This cannot be 4, that cannot be 4. No, 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 no. That's not it. There's 9 somehow. That cannot be a 3-6 pair. That's it. Um, that cannot be a 2. There could be a 2 on there. That cannot be a 2. There can even be a 2 on there. Okay, no. Sorry, but where I just got stuck on this region puzzle. Irregular regions. Come on, man. Show yourself. Um, show me what you want me to do. So what have I not used? Maybe that's an idea. But 8 can just go with 1 and we're fine. Ones in some region. No, that's not it either. So what can we do that I have not looked at yet? Because I feel like I've just been doing 10 minutes of ending the puzzle, right? With no forward progress. 1, 2, 3, 4, 5, 6, 7, or 8. Okay. 6, 7, or 8. With that not being 7. That not being 8. No? Really? Really nothing? Um if that's a 3, that's a 3, then that's a 3, then that's a 3. There's already 5, so then I place 4 more. So that's one scenario. Or there's the 3 there, then there's a 3 there, and there's a 3 there, and then there's a 3 there. So what happens if that's a 3 then? And that's a 3, that's a 3, and that's a 3. And if that's a 3, so what happens if that's a 3? Then that's a 3, that's a 3, and that's a 3. Hmm. I'm just working out probabilities at this point. Um, not any conclusions. Um, nines maybe, because that cannot be a 9. Those cannot be 9s. That cannot be a 9. So that is a 9. Wow, is that useful? Now there has to be a 9 on this dot. Yes, it is useful. Okay. So that's a 5-6 pair. So I have a 5-6 pair there. So that's not a 5. Maybe 9s, more 9s. No, 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 no. It wasn't as big of a thing as I thought it would be. What that is a 9. Where is the other digit going to go? 5 is 6. Because if that's 5, then that's 6, and that's obviously not 5 or 6. But these are the same digits, so the other digit is going to go there or there. So with other words, this is 5, 6, and 9, making that the only place where 1, 2, 3, 4, 5, 6, 7, 8 can go. So 8 cannot go there now. It could go with a 1 there. Okay, that's. If these are both 5, that's 5, then that's. Oh, no. No, that means nothing. I thought I was being smart, but I'm probably not. I'm just not seeing anything. Wow. Sometimes you just have to struggle at the end. And this is one of those puzzles, and that's okay. I even these cannot contain 5. What am I doing? Why have I made this pencil mark? 1, 2, 3, 4, 5. I need 4, 5, and 9. I need 4, 7, and 9. So that's not 9. That's not 4. 4 cannot be there. Can you for some reason not be there? No. Okay. So what are we looking at? what what is happening? What's going on? 1, 2, 3, and 7. 5. If 5 cannot go there, we have something. Because then either of those has to be 5, and then this cannot be both 5. This cannot be 6. That works. That works. That works. Because if this cannot be 6, then these all cannot be 6, then that cannot be 6. Because if that's 6, that's 3, and that doesn't work. So one of those is 6. So these cannot both be 6. So they're both 5. So that's a 6. So that's a 5. That's not a 5. Seriously? That does nothing for me? Uh, that I don't know why, but that just feels it didn't do nothing, but that just feels insulting. In a it's like that sounds so negative, but I truly find that funny. I don't know. It's just such a hard fought nothing that you know you fight hard and you receive nothing to compensate. I don't know that. That's I don't know. For some reason that's also what pulls me to the 5-star puzzles, but they just don't do well in video form because it's me 4 hours long staring at a puzzle, and I personally enjoy that. I don't know if I would enjoy watching someone do that. I would advise you to do those things just by yourself in Sudoku, and that's only if you enjoy it. Because if you don't, you just wasted 4 hours. Um, but if you enjoy it, it's very, very rewarding and positive whenever you reach the point of breaking the puzzle. That being said, this is now not 8 anymore because it cannot be 5. with it. So it's either 3-2 or 3-4. I'm going to pencil mark that. That's not 4. So we have a 1, 2, 3, 7 there. So that's a 5 with a 2. Oh no, that's not necessarily true. That's like this. But we do have that. Oh, we do have that now. So that's 4, 7. So that's a 7. That's a 4. And this is a 1. That's the only thing we need in the row. So one of those is a 1. Hmm. 1, 2, 3, 4, 5, 6, 7. So we need 8 and 9. But still. Oh, the 9 here fixes that. That is something you're just going to miss things when you're doing the scanning. It is difficult. That's not 9. That's not 9. So that's the only place 9 can go. Let's see how many more 9s. We need a 9 in these two columns, and they are dispersed here. We don't know which way around. So that's not 4. So we need a 7 or an 8 to break them up, but we don't know which one. Okay, that's fine. What am I missing here? Oh, that's 5. The 5 fixes the 2 and a 5. 5s maybe. I need 5s in these two columns, and they have to go in one of those two and one of those two. So that's 4. You're 5. You are then a 4, and then you are a 5. I stutter because I thought that couldn't be a 4. I don't know why, but I saw, but I saw wrong. Um, I need a 4, and it's going to be in this column exactly there with a 3, with a 3 and a 1. That forces that to be a 3, that to be a 3, that to be a 2, that to be a 2. That's a 1, and then we have the 7, we have the 9, we have the 7. Oh, yes, okay. It's all coming together now. Um, that's now a 1. How many ones? Which one am I missing? I am missing this one. I'm missing a 2 in the first, in this row and this row. This is the only place 2 can go in this row. This is the only place can go in this row. Now I'm missing a 6, 1. I'm seeing 2 2s. Why am I seeing 2 2s there? 2s. I'm missing a 2 in this row. Oh, I looked at the wrong row. Okay, but that's still true. That's like this, and that's like this. Okay, I hope I haven't made another mistake like that. Now, what am I missing in this region? It's a 7. That's and I'm missing in this row. I'm missing an 8. What am I missing in this region? It's a 6. Now I'm missing an 8 there, a 6 there, a 7 there, an 8, a 6, a 6, an 8, and a 6. Thank you. Thank you so much. Thank you for watching. Thank you for this puzzle. This puzzle, I don't know why, but it somewhat infuriated me in a very positive way. It really fueled a fire, especially the ending. Um, I don't know. I don't know. I really appreciate this puzzle for what it is. It's an amazing 3-colored yin yang, even though it's mostly 2-color yin yang. However, it is a step towards what I wanted to do for my. Uh, it sounds so weird, but a 10 subscriber sort of special. I wanted to do. I think it's called "Flowing Rivers" by Icy Fruit. It's a very old puzzle, and I've always wanted to do it, but I haven't sat down for it. And it's probably going to be a very long video. Um, but I'm very excited to to do it, to try the puzzle. And if I get nowhere, I'll still upload it, and so you can sort of see the progress. Maybe I'll do it, multiple times and see how we do. But thank you so much for watching this puzzle, and I hope you have a nice day. Thank you.